the horizontal asymptote is at y equals 1. So that's x. And then problem is there's no x-intercept, right? Which means that's where the hole is. It's at x um, plus 3 and then x plus 3.
Got it. So the hole would have been -3 comma 0, not
Yeah. So that's got to be there. We're still missing, though, the horizontal asymptote at y equals 1. This one doesn't have that. So let's see here. Um,
yeah.
how
The
did your
one,
teach?
the vertical and horizontal symmetry are on the graph, I think, just that it's really well blended into the graph, but it's
Well, yeah, I mean, you need another factor here. So if you put 0 in for x, you get 3 over -1 times -3. You need another, you need
3.
another like, something here to get it to -3. So
Wouldn't actually no, that'd be
because you have 0 plus 3.
wouldn't it have to be x minus 3 then? The only option that could be there in order to make it -3, because
Well,
if you
well,
were to
that's
make everything 0, that would get you -1 by being times it by 3.
so
So,
I'm thinking plus 3 gets you to what you want.
oh yeah. So then those two are the whole like the 0 plus 3, 0 plus 3. So, or the
Yeah.
x plus 3.
Truly, we didn't actually look at an example like this where there was a hole there. And I don't know. That's your teacher. The way they are. So that satisfies everything. And then you can, I don't really know why you got the x-intercept, y-intercept, and hole wrong. I mean, they're literally on the graph, but maybe you just, you know, missed them. Now, the domain we did cover. The domain we talked about length, which is it's broken up by the hole. Same with the range. That one I'm a little bit more surprised about. What would the range be? I remember it's
The
broken up by that
range
hole.
would be -infinity to 0 union 0 to positive, or 0 to 1. Yeah, 'cause there's the, hold on,
Union.
straight 1 and then 1 to positive infinity.
Yeah. Okay. And he didn't, I mean, y is fine here. He doesn't say function. I mean, it's fun. This garbage. I mean, y equals f of x. I mean, they're the same.
I think the two ones that I was for the, yeah, there's
Yeah.
yeah.
I don't know. And it's easy to look at. I don't know. I sort of thought this was -5 myself when I looked at it. I don't know. I don't like when they're gridded by 2. That's just always a little weird for me. All right. But that is everything on that one. Like
Yeah, I
5.
think the next one we kind of need to go over all four of them,
Okay.
because a lot of them have like each of them have quite something, so
Yeah. The first one, you got to restrict the domain. You can say, okay, x plus 1 cannot equal 0. You should factor this one first. X minus 1, x plus 1. So x minus 1 cannot equal 0. So basically, x cannot be 1 or -1. You get either of those, you should just say, okay, that's not right. So now you do want to make a common denominator. So you got to figure out what each of them are missing. What is the first one missing? What is this one on the left here missing?
you need to multiply the denominator by x minus 1,
X minus 1, yeah.
and then on the other one you need to multiply it by x plus 1, x minus 1, both none
Yeah.
the top and bottom.
And you don't really have much room to work with, but you got what you got. I mean, uh, so why don't you do this for me? Why don't you refoil this and I'll do the other side.
The numerator would be 4x squared plus 3x
Minus
minus
3x.
1. Oh, we have
So
minus
4,
2,
4x minus 1 is minus 4x, and then plus 1x.
and then minus 1. And
Yeah.
then the denominator would be,
The
x.
denominator doesn't matter. You
Oh yeah,
don't need
because
anything
the
to do with
common
denominator.
denominator plus 3, so then
Now we're
you
going
would
to move
have
everything
to, yeah,
left.
subtract the, it's
And this is 9, so you're going to subtract 9. So you're going to be like x squared minus 3x minus 10 equals 0. Go ahead and factor that, and you'll find that both of these answers do work.
fine.
We can look at 6 now. All right, so one of the things that I would do here is I would recognize that this minus goes with that. But you still have to set x not equal to 0 and x plus 1 not equal to 0. To both x cannot be 0 or -1. You're just on the lookout for those. Then you rewrite as your common denominator, and you figure out what each one is missing.
Got it. Oh yeah, now it's kind of thinking like what we were supposed to do. So you would multiply x plus 1 for 4 over x, you multiply x plus 1 to that on the numerator and denominator. And
Yeah,
then -2 over x plus 1, you'd multiply x on the denominator and numerator. And then 3 over 1, it would just be multiplying it by x plus 1 and by x on the numerator and denominator. Yeah.
right. And
So
you actually
that's
now
it.
you don't care about the denominator at all. That's the key thing here. Like I mentioned, that negative goes with the 2. So you really only are looking at the top.
Got it. So then in this case, it would be 4x plus 4 minus 2x equals 3x times, sorry, 2x squared plus 3x, yeah.
Okay, so this time I'd move everything right.
So
And
minus 3x squared on both, oh, no, everything right. So
yeah,
minus 4x, or or,
then see if you
yeah,
can
minus
factor
2x on
this.
both sides. Can't really do 1/2. But, 3x squared. So you would have to do quadratic for this?
Well, No, not necessarily. The way you factor this is you multiply 3 times -4, you get -12. And you're looking for two numbers that multiply to -12, but add the positive one.
Why wait, no, -12. So in this case, it'd be -4 and 3, because, all right, -3 or -4 plus 3, but that would be negative. Wouldn't it be -3 and 4?
Yes.
Yeah, because -3 plus 4, then you get 1, and it's -12. Okay, so then it's 3x minus 3, and then x plus 4.
Yeah, so you get 3x. What'd you say? X minus 1 plus 4, something like that.
Wait, what would it be? 3x plus 4 and x minus 1. Wouldn't it be
So yeah,
3x
you
minus
factor up the
3 and
3x from
x?
both.
Oh, okay. Got it. Got it. So the other side would be, oh, the group. Yeah, I get it now.
All right, so this becomes +4, and then you pair them up.
Yeah. So x equals 1 and 3x plus 4 equals 0, or minus 1, 3x. So x equals -4 thirds, and x equals 1.
Yep. Now, are either of those excluded? Nope, you're okay.
No, neither of them are excluded. So it's mixing a solution.
All right. Ready to move on to the next one?
Yeah, number 7.
All right. So kind of the same deal. Um,
If I remember right, I think it was number 7 and number 8 that I got stuck on, and then I went to the next page, finished the rest of them, and then came back to it. So I think these two are I think number 8 was the one that I ran out of time for when I came back. But number 7, I didn't quite understand how to do it, but
it's a 10 up here. I can't. Oh, it's a 1, right?
yeah, it's a 1. I was multiplying it
Yeah. So I
by,
mean, it's really no different than what we've been doing. You still set the x not equal to 0, the x plus 2 not equal to 0. Um, and you now make your common denominator. So it's 2 over x plus 2 minus 1 over x equals -4 over x times x plus 2. And same thing, you just figure out what's the missing denominator.
okay, so you just multiply x by the 2 over 2x plus 2.
Yep, these both get an x.
And then the other one would be multiplying it by x plus 2.
Yep. I think what you missed is that when the bottoms are all the same, you just look at the top Negative goes with that. That's also an easy thing to miss. They really like to emphasize that on tests. So you have 2x minus parentheses x plus 2 equals -4. This is actually the easiest. So go ahead and solve this.
Okay, so it's more x plus 12 equals -1. X plus 12 x equals -3.
So do you get 2x minus x minus 2? Make sure you distribute that negative
Oh,
both.
I thought, I thought I saw that as a 12. That's why. Okay, let me fix that.
There's the one where when you solve it, you get a number that is not allowed. It's not in the domain.
Plus
So this is no
2,
solution.
and x, that makes it x plus 2 equals -4. Minus 2 makes 2. What is plus x equals -2, yeah.
All right. Okay. Uh, so yeah, when you run out of time, I mean, there's really no way to know he did or didn't know how to do it. But um, I'd like you to factor this one on the left, please.
Alright, so let's see. X minus 4x, wait, yeah, x minus 4x minus 3,
Yeah.
or x minus 3, x minus 4.
Now this one in the middle here looks a lot like that, except it's in the wrong order.
So you
So
take the
3
negative
minus,
out, and then it becomes positive, so then it's x minus 3.
yeah. And so that negative can actually go. So it's really
Yeah, so
plus
it's x
2.
minus over x minus 3, which
Yeah.
means that you could I could have multiplied x plus 3 by that and 2, and then equals 5 times x minus 3 over x minus 4 times x minus 3, which would have made all the denominators the least common denominator. The common denominator.
I messed up here. There's a minus. So why don't you try solving it from here? You seem to know what to do. You tell me what you come up with for the top. I'm also noticing a trend where your teacher actually makes the earlier problems harder than the later problems. I wonder if that's being consistent throughout her tests. But this one's
Yeah.
easier because it ends up being linear. You don't have to solve a quadratic.
Five over x plus 7 equals 5x. I got x equals 4. Oh wait, oh wait, 1 second. I think I got x minus 4 x 3 is not equal 0. 4 plus 4 x cannot equal 3 x cannot would this be no solution because one of the x cannot equal the domain restrictions would be x cannot equal 3 and x cannot equal 4. So when you solve it, you get x equals 4.
Yeah, so let's see here. Yeah, -3, add 3, 12 equals 3x. Yeah, x equals 4, which is not possible, so no solution. Good. Like I said, like these last two were actually easier because, like I said, you didn't have to solve a quadratic. I'd almost want to look at your other tests to see if they were the same. Because that pattern will continue throughout the school year. Like you might find actually starting from the, you know, end and working back.
I do find that most of like some of the questions I get stuck on sometimes are the first few questions that are usually like sometimes a little bit harder than like the last question, for example, in this test, which was a lot easier. The
Okay.
last page, the last four like questions were like the easier.
Yeah. I mean, they don't talk about that in school, but that, in real life, you don't have to do things in order. You do them in the order that matters for you and what you're doing. You have autonomy, make your own decisions with that.
Okay. Let's go over. Let's go over number 9. I don't think we really talked about that question a lot. Or we didn't talk about that question when we were going over the test today.
All right. So to do number 9, you have to sort of know that it's what the graph looks like, meaning that, and it's easy when you have the answer there, but the graph, it's broken apart right there. And it's the only way that happens is if it's got a horizontal asymptote. So which of these has a horizontal asymptote? Well, they all do, but which one has one at 1? So 1 and 1, 1 and 1. So A is out, right?
Yeah,
It's at 2. That's thing 1. Um, you and I really didn't look. I guess we looked at a little bit of these. Um,
but
you know, I
if the so the degree is if it's the same degree, then it should be at
right,
one.
but so like your argument's like, oh, it could be any of these, but these actually have other shapes to it. I don't know if you had a calculator. If you were to graph
This
these,
this entire test was no calculator.
okay, so that's where you would want to start with the low hanging fruit. I mean, B and C, you got a factor. I got x minus 2, x plus 2, x minus
Oh,
2, x plus 1. And then you're like, oh, at minus 2, there's a hole, which will affect the domain or the range and the domain, right? Same thing on this
so
next one.
you're
It's like, all right,
basically using the other range, which here doesn't show having a hole. It just
right,
shows having a horizontal
horizontal
asymptote.
asymptote.
So
Yeah. It is
so
a
that
good
automatically
question.
would rule out those two, which would make it the
Well, I mean, I can see kind of why you're leaning towards C. But again, it's got a hole. That,
yeah, the
so, I mean, it's easy in hindsight, really, it is. But you gotta, you gotta persevere through all that.
yeah, I think the
Um,
other one that I kind of got stuck on to come back to was number 13, I believe.
okay.
So let's go through those for their next.
Right. So the challenge here is the factoring. Um, remember I told you that you take the first and multiply by the last. You only do that when there's multiple like factors. It's better to just guess and check. if you can. If you don't like with that, I mean, I understand. Like I'll do the one on top here. The factors of -5 are either 5 and -1 or -5 and 1. So to get to 9, +5 -1. You can sort of guess and check the numbers. 10x -1x gets you to 9x. That's one way to do it. But you got to be able to factor all these. So I'd like you to factor the bottom two.
Yes, I got 2x plus 8, x minus 1 for 2x squared plus 7x minus 4.
You can only use 4 and 1 though. 4 and -1, -1 and 4, or 2 and 2.
Uh, um,
Like
wouldn't
like
you have to
like
multiply the
you
two
can
times?
you can, but that's the slow way, and especially when there's only one factor of like 2x, 2 and x. That's why you don't do it.
But wouldn't it have to add to 7?
It does not. The O and the I though do. 8x and -1x do. The last one's the better example because there's only one factor of 5, 1 and 5. So it's either +1, +5, or +5 and +1. And you'll see that one of those work.
Okay.
We didn't really cover this because it's like an advanced technique.
Yeah, I think, yeah. So whenever you're doing like this, you would have to put 2x and x and whatever factors like can multiply to get c, which is the like last number, the -4 in that example.
Right. Well, you can do that. Like that's -8. So it's two numbers that multiply to -8, but add to +7, which is 8 and -1. And then you pair it up, 2x squared plus 8x -1x -4.
Got it. Yeah, then when you yeah, yeah, I can see. So you'd be then grouping those.
Yep, you can group, the first two, take the 2x out of both, -1 in the middle.
Oh yeah, then you eventually do get the 2x minus 1x plus 4. Got it. Got it. Then you do the same thing for the other equation.
Okay. Yeah. I mean that, and yeah, so go ahead and do that if you want.
So like the quicker way to do it would be to put
Like two only
whatever's
has
in
two
front of the x.
factors.
Yeah. And
5 only
then
has two factors.
you would have to find whatever multiplies to 5, or just in this case would be just 1 and 5.
Yes.
So it'd be plus 1 plus 5. So 2x plus 5, or plus 1, and then x plus 5. Or
So +5 +1.
Yeah.
And then you just start canceling out whatever you see that's the same on the top and the bottom. And whatever's left over is
So that
worth
gives you
it.
x minus 3 over 2x plus 1.
All right, any questions on that?
Um, no, I think I get it now.
Okay. What else would you like us to look at today?
Um, let's also go over number 11,
11. All right. Yeah.
11, 12, and 14, those three as well. So let's start off with number 11.
Yeah, so right off the bat, whenever I see a 2 minus x or a number minus x and a minus in front, I know that probably it's going to be a plus x minus 2, probably. Yeah. That's just something to sort of hard code that probably becomes that. What does this factor down into on the bottom?
Um, that, that would factor to x plus 4, x plus 1.
Yeah, x plus 4, x plus 1.
All right, and then
Now, what are you going to make the common denominator?
the common denominator you'd multiply 3 over x plus 1 by x plus 4 on the numerator and denominator.
Right. And like I said, probably better to change this to x minus 2. And then,
Yeah, that way you're able to easily see if it's cancelable.
yeah.
Got it. And then after that, you wouldn't really have the denominator, so it would just be 3x plus 12 plus x minus 2.
Yep. Do those combine?
So 3, 3x plus 12, and then x minus 2, x minus x plus x, so 4x plus 10, which you can back out, uh, 2, so 2x plus, so 2 times 2x plus 5.
So we got 4x, yeah, minus plus 10. You're just looking to see if anything cancels.
Uh, uh, so,
All right.
so nothing here would cancel.
Yeah, nothing cancels.
So then that would be the answer.
Yep, that's it.
Got it. I think I kind of got confused and tried to try to equate it to 0. Yeah, it would kind of, you would not.
I mean that I see that I mean that clearly like what's going on here is because you got into the pattern of solving, so you're like, why am I not solving here? And it's truly the way the brain works is you do the same thing over and over. So this one here, again, that minus, this becomes x minus 5. So again, it's actually much simpler than the previous one. Because you can combine the top basically done.
Alright, so then 3x plus 4 plus 6. So 3x plus 10. 0 minus 10. Oh, wait, wait. Equate to 0. Um, 3x plus 10 over x minus 5
Yep,
is what
that's
that
it.
would equal to.
That's it.
Oh god, I think for some for like most of this question these questions, I think I was trying to equate to 0 to solve it
Yeah.
instead of like simplifying it by using multiplication or division or whatever was here.
Yeah, I mean, you
Doesn't
could actually argue with your instructor that domains are only applicable to functions, um, which leads you to think that you're doing something here, but I don't think you'll get very far with her on that. The instructions are not clear. The instructions should have said to simplify. Nothing more, nothing less.
okay, so
But
then let's try number 14 next.
sure. And we actually have not done any of the domain and range stuff or domain stuff, so uh, keep that in mind. Like we should be setting the bottom not equal to 0. So x cannot be 1 or -1. All right. So this bottom one factors into x minus 1, x plus 1,
Yeah, and
and
then
then
so
the
that
top.
now matches
top
the sketch. And now you have to multiply 2 over x plus 1 by x minus 1, and then 3 over x minus 1 by x plus 1. So then that would turn into, oh yeah, so now the bottom is all common denominators. So that would be 2x minus 2x minus 2 plus 3x plus 3, so 5x plus 1. So then wouldn't it be 5x plus 1 over x plus 1, x minus 1 times x minus 1, x plus 1 over 4? Because you're multiplying by the reciprocal.
That's right. And does anything cancel?
So then x plus 1, x minus 1 cancels on the numerator and denominator. That leaves you with 5x plus 1 over 4.
Yep.
Yeah, nothing can cancel that. So that would be the answer.
Yep. All right. We are going to stop here for today. A good
Yeah,
stopping
because I think
point.
that, yeah, I think as you can see on like the next page, like the